O'Reilly!
It's Superstart Battery Month at O'Reilly Auto Parts. Get up to a $25 gift card after rebate with the purchase of select Superstart batteries. Our professional parts people will test your old battery for free and recommend the right battery for your vehicle. For power, performance, and reliability, choose Superstart batteries only at O'Reilly Auto Parts.
O'Reilly Auto Parts.
Today's show is brought to you by ExpressVPN. Protect your online activity today and find out how you can get 3 months free at tryexpressvpn.com/space. That's tryexpressvpn.com/space for 3 months free with a 1-year package. Visit tryexpressvpn.com/space to learn more.
15 seconds. Guidance is internal. 10, 9. Ignition sequence start.
Space Nuts.
5, 4, 3, 2.
1, 2, 3, 4, 5, 5, 4, 3, 2, 1.
Space Nuts.
Astronauts report it feels good.
Hello again, and thank you for joining us on Space Nuts, the astronomy podcast that we bring you every week from all corners of the world. We have an international audience. There's people from Australia and Tasmania who listen, and there is also Professor Fred Watson. That was an inside joke. Fred will understand it.
Yes, indeed.
And
it's very nice to...
Tasmanians will be sending me brickbats.
Well, you deserve them.
I know.
Yeah, it's a great place, is Tasmania.
It is.
I
It's
love
lovely.
Tasmania.
Actually, you know what? I can redeem myself by saying that's where Judy and I spent our honeymoon.
Oh, well, there you go. All right.
But yeah, I love Tasmania. It was January and it was freezing. It was
that's
absolutely
why you
freezing.
go.
Yes, true. That might not sound unusual to anyone on the northern side of the equator, but January here is one of the hottest months of the year. So it's a bit bizarre. Everything's sort of flipped on its head. Anyway, Fred, hello. Nice to talk to you again.
You mean it's another week? We've got to talk again?
I know.
Good heavens.
We try to avoid each other at all costs, and it just never works. It's like marriage. Now,
don't even go there.
It's too late. It's way too late. We're going to talk about moonquakes because they have been confirmed. And the beautiful part of this story is that they've used technology from 50 years ago to figure all this out. I think that's awesome. We're also going to look at something NASA's done. They've done an asteroid striking Earth simulation, and it ain't pretty. And the story I came across today, Fred, that I thought was worth mentioning because Australia is involved, and that's the Square Kilometre Array, which you and I have discussed. But they've got a new supercomputer, in fact, 2 of them, that they're going to create for part of the project, which will be the biggest supercomputer ever made. So we'll look into that and some questions. One about the orbit of the International Space Station. Why is it so is basically the question. And another question about life in our galaxy. Yes, no, maybe. We'll get to those. But let's talk about moonquakes, Fred, because they have basically used technology from, I think it was about 4 Apollo missions to analyse what's happening on the moon, and basically she's doing a bit of a shimmy.
Indeed, that's right. So we've kind of known about the moonquakes since the Apollo era, because I think it was for 9 years those seismometers that were left on the moon by the Apollo astronauts, and you're quite right, it was 4 of those missions. There were 6 missions that actually had astronauts walking on the moon. 4 of them deployed seismometers. So during that period of 8 or 9 years, which was the time that these instruments remained active, which is pretty good going because they were all solar powered. They probably had batteries that were 1969 quality batteries. They wouldn't be all that brilliant, and they lasted for that time and sent back copious quantities of data, thousands of moonquakes, and by the technology of the day, you could kind of triangulate between the different seismometers. You've got 4 of them on the near side of the moon. They're not very far apart because they're all kind of in the equatorial latitudes of the moon, and they're all on the near side. And it's by having seismometers a long way from each other that you can really see what's going on inside a planet. We use it on the Earth all the time. And of course, as you and I have mentioned, there's now a seismometer on the planet Mars, courtesy of the InSight lander that's there, which has detected a Mars quake.
It has.
On the moon, as I said, thousands of moonquakes were detected. But because of this fairly close separation of the seismometers, it wasn't really possible to locate them, particularly the shallow ones. The deep ones you could get a handle on, and we believe that the moon's interior is still cooling down, and that's what causes the deep moonquakes. But it's taken until now to really find out what's been going on with the shallow ones, and it comes about because of another NASA project. Kind of 50 years later, not quite actually, I think it's been in orbit around the moon for probably the best part of a decade already. Lunar Reconnaissance Orbiter is a NASA spacecraft. It orbits the moon. It's done the most magnificent high-resolution imagery of the moon's surface. You and I have talked before about the fact that Lunar Reconnaissance Orbiter has sent us back pictures of all the Apollo landing sites.
Yes.
And you can see the footprints and the buggy tracks and the base of the lunar modules all sitting there.
The McDonald's chip packets.
The chip packets and everything, that's right. But more especially, I'll ignore that one. What Lunar Reconnaissance Orbiter has done is allowed fine resolution imagery of the surface, of the natural features on the surface. And what they've done, the scientists who are running the show, is that they've found all these youthful-looking fault scarps. And you know what a fault is. It's when the land slips vertically with respect to the other half. There's a line that divides 2 bits of land, and one is slipped vertically with respect to the other, and you get a fault. We've got many of them in Australia.
Yeah, we have. They're all over the world.
Yeah, indeed, that's right. So these but they look youthful from the imagery, and by that I mean that their edges are sharp. You've got something that's obviously moved within the recent past, and erosion, because erosion does take place on the moon, even though it's very slow, hasn't had time to round all the edges off. Old features tend to be more rounded. These look quite young. But what is the clincher on that is that it was Apollo 17, the final Apollo mission, crewed by Gene Cernan and Harrison Schmitt. They saw one of these faults when they were on their Apollo 17 mission, and they actually drove to it on the moon with their moon buggy and grabbed some rock samples, and those rock samples showed that it was a very young structure, that the scarps probably were younger than 10 million years, and that's young in geological time.
Certainly young in astronomical.
It's young by comparison with us as well, but it's quite useful. So there's this clinching set of evidence. The Apollo guys found the rock by one of these young-looking faults and demonstrated that, yes, it is young-looking. But now knowing where these faults are because of the Lunar Reconnaissance Orbiter survey, the mission scientists for that have identified, I think, 3,000 of them. It's a huge number. And so what they've now done is built that knowledge into the records of the seismometers that Apollo left on the moon. And sure enough, it turns out that you can actually locate many of the tremors to these fault areas. It's a lovely piece of science with data separated by 50 years almost. But it actually demonstrates that there is tectonic activity happening on the moon, because these moonquakes, far from being mostly caused by meteorites, which is what everybody expected, because people expected the moon to be tectonically dead, just nothing happening there, nothing to see, please move along. It's not like that at all. It looks as though the moon's surface is still active, and what is thought to be causing that activity is the shrinkage of the moon as its interior cools. So as the moon cools, it gets smaller because it's contracting, and that contraction actually causes the fault lines on the surface and gives you these moonquakes. There is one other piece of clinching evidence with this, Andrew, which I've failed to mention so far, and that is that these things were more common when the moon was at its nearest and farthest points from the Earth. And those are the points where you've got the biggest tidal stress on the moon.
Oh, so it's a combination factor. So it's the shrinking of the moon and its position in proximity to us in terms of its gravitational effect.
So what you've probably got is the moon's shrinking all the time, but it takes a little bit of an extra bit of stress to push the fault into a little bit of slippage. Then gives rise to the moonquake.
Wow.
Very, very nice science indeed. And, I think it reveals a mystery, actually, because the current thinking has been that the moon is cold and dead. Its interior really doesn't have anything going on inside, nothing molten like we've got in the center of the Earth. Remember, the moon's only a quarter of the diameter of the Earth, so it would have cooled much more quickly. And yet it's still got enough heat that it's losing that heat and causing the contraction. So the mystery is, where is the moon's interior heat coming from? It sounds as though there's more heat coming from the moon's interior than we expected. And maybe that might give rise to another moon mission, a bit like InSight, which has a temperature probe on it, which is currently stuck, I think, as it tries to burrow down into the ground. But the temperature probe is designed to show how much heat's coming from the interior of Mars. You could do the same sort of thing on the moon. I hope NASA is listening to Space Nuts, because they're full of ideas for future.
I often send it to them. I do. I
bet you never get a reply.
Not really, but I never expect one. Is it possible that the activity of Earth being a bigger body is perhaps causing a friction effect inside the moon and heating it up? Like you look at how the gas giants impact on their moons, and some of them are quite volatile because of
yes, that's right.
The gravitational effect.
Yeah, so you're thinking of Jupiter and its moon Io, which is the most volcanically active body in the solar system because of the gravity of Jupiter being right next door. Yes, there's an element. I'm sure there's an element of that, because we know that the tidal effect of the Earth is actually imparting energy to the moon. The Earth itself is giving up rotational energy, which is why we need leap seconds every now and again. And that energy is going into speeding up the moon. So there are definitely forces at play there, which could indeed be contributing to that. I think that's locked up in what we were talking about, the fact that the moon is nearer and further away from the Earth at different times in its orbit. Plate tectonics on the Earth is unlikely to have any direct influence on the moon. It's got much more of an influence on what goes on here, and that's why we can't see ancient craters on the surface of the Earth, because, at least not terribly ancient ones, because they've all been rubbed out by plate tectonics.
Yes, indeed. That's fascinating, though, and it's. I just love the fact that 50 years on, we've now developed the technology to analyse the data from Apollo and go, oh, now we know what happened.
Exactly, quite so.
It's awesome. You're listening to Space Nuts. Andrew Dunkley here, and Professor Fred Watson. Now, let's take a little break and find out more about our sponsor, ExpressVPN, rated #1 by TechRadar. This is the one I use. I've been using it for a couple of years, and I love it. When I joined ExpressVPN, they were brand new to the market, but I read a lot of reviews and did a lot of comparisons, and there was just something about their business model that I particularly liked, and a couple of years down the track, honestly, can't complain. Their interface is very easy to use. Their service is second to none. I've had to contact them a couple of times about certain things that I wanted to do, and they were brilliant. So you may be wondering why I do need a VPN at all. It's all about privacy. Do you really want big tech companies, governments and others knowing what's going on with your online activity? Even if you're having nothing to hide, it just feels downright creepy. I think you'll agree. And governments are getting more and more interested in what you're doing every day. And so, protecting your privacy is what VPN is all about. And how often do you run across websites that you want to get information from only to find that they're geo-blocked? This is becoming an increasing problem, but ExpressVPN solves that problem for you. Now, if you go to our special URL, you'll see quite a list of things this service can help you with, things you may never have thought of before. As I say, it's the one I use, secure, fast, and it just works. So protect yourself online today and find out more about how to get 3 months free at tryexpressvpn.com/space. That's tryexpressvpn.com/space for 3 months free with a 1-year package. Try expressvpn.com/space to learn more, and you'll find the link details in the show notes and on our website. Now, back to the show.
Okay, we checked all 4 systems and keying with a go.
Space Nuts.
Now, Fred, a fascinating story from, strangely enough, NASA. It's about a simulation they've done to see what would happen to Earth if it was hit by a huge rock. Now, we've talked about this before and, talked about different sized asteroids and what sort of impact they might have. Chelyabinsk is the most recent significant event that we've seen where people were injured, thankfully not killed, by the explosive effect. But then we got into talking about bigger rocks and what might happen, this, that, or the other. Well, now NASA's actually done it to see what would happen. How big a rock were they playing with?
Well, at the end of the day, it was 60 meters, which is 3 times the size of the Chelyabinsk object. And so you've got rather more than 3 times the destructive impact. So the story here, Andrew, is I think this is a very nice piece of work. There is a conference which I think is now over. It was somewhere near Washington, D.C. in the United States, and it is the Planetary
That's
Defense...
called Congress, I think.
might be called Congress.
It's
yeah.
all over.
The non-Congress conference was the Planetary Defense Conference, and so it was all about experts on how you might deflect asteroids and what asteroids can do when they impact, and of course many from NASA and many from the European Space Agency, and what they did was they kind of played war games in a sense with asteroids. Mm-hmm. They had 5 days of the conference, and essentially the organizers simulated a developing situation over 2 fictional years. And what they did was they basically tweeted people with what the latest was. So you were sitting in this conference, presumably listening to many learned talks, while getting tweets saying we're all doomed or things to that effect. Of course, everybody knew that it was a simulation, and every article I've read about this is at pains to point out that this is a simulation, because at the moment there is nothing we know about capable of hitting the Earth for at least 100 years. We've kind of established that reasonably well. But, okay, what happens if we do find a near-Earth object and it looks as though it's threatening the Earth? So what they did was they simulated the discovery of an asteroid which they named 2009 PDC. Now, PDC, of course, means Planetary Defense Conference, because it's not the normal way that you name asteroids. It would have letters and numbers if it was a conventional name, but it's fictional. So it's 2019 PDC, and the initial observations suggested that this thing would actually be a likely impactor in the year 2027. Actually hitting somewhere near Denver, Colorado. And they estimate that this thing is 260 meters across. Now, that's big enough to do definitely statewide damage. You're talking about a huge disaster area. And so, but they've realized that they've got 8 years to do something about it. So they organized to send impactors to deflect the movement of the asteroid, which is what we would do if we found an asteroid that had that long lead time. 8 years is reasonably long time to do something about it. I think the simulation said they built and launched half a dozen spacecraft with what are called kinetic impactors. These are things that you really blast into the asteroid just to push it off course rather than blow it up or anything. So they did that. Apparently in the simulation, three of those missions were successful, not all six, but they had a kind of unexpected disaster in that while the main part of the asteroid was deflected so that it wouldn't pose a threat, a 60-meter chunk broke off. And basically, that was the one that they had to deal with because it was heading straight for the Earth in 3 years down the track, so 2022. And then, there were all kinds of, you had to debate what you're going to do. There was talk of a nuclear weapon to take it out. That, of course, always gives you the risk that you just wind up with a whole lot of smaller stuff coming down in the same direction. But in the scenario, I thought this was quite a nice touch. Apparently, Washington, the US government, was crippled by political disagreements, and so nothing happened.
Well, that sounds very human.
It does, yeah. But in the end, it comes down to civil defense. They've got this thing coming in at nearly 20 kilometers per second with probably an airburst and over an area something like 10 kilometers across. You've got total devastation. People would not survive it. So you've got the issue of trying this. Oh, I forgot to mention it's aiming straight for New York. Just as a.
Why do they always pick on New York?
Well, it's kind of.
Why don't they have a crack at Trundle or something?
Well, Trundle's okay because there's only 90 people living. I know. All out on a bus.
They haven't got the internet yet, so it's safe that I can say that. No, they have got it.
I like Trundle. I think you'd not Trundle. It's a great place. Isn't Trundle where they've got the widest main street in
Australia? Because they used to do U-turns with bullock teams.
Exactly.
That's why that's true. And I used to go there as a kid. My uncle was the bank manager there, so we went there for holidays. I love Trundle. I think it's a great little town.
I did a gig there.
I just like taking the mickey out of places.
You do take the mickey out of it.
People take the mickey out of Dubbo all the time. So, it's payback.
So why wasn't Dubbo a target for this simulation?
Yeah, I don't know. It probably
there you go.
It's been a target for everything else for so long.
Yes, that's right. So the simulation says you're going to trash New York, and you've got the problem of getting people out of the way. And I think that's where it kind of came to an end. But what it highlighted was some real science technology, not science fiction, but real science, because there are two missions, and I think this is a collaboration between NASA and ESA, to send two spacecraft towards an asteroid, which is an interesting one because, like several asteroids, it's a binary system. So you've got a big object and a small one in orbit around one another. And what I think they're going to do is try and knock the small one out of its orbit, or at least see whether you can deflect it to give it a try. So they'll launch in 2 years' time. ESA's will launch, I think, next year. It might even be this year. NASA's will launch in 2 years' time. And the project is called DART, which stands for Double Asteroid Redirection Test. And it's designed to see whether we can shift an asteroid. It's not an asteroid that has any threat to the Earth. It's perfectly innocent. By the time they finish with it, it might be. You hope that everybody will get their sums right. But it's an ideal one, they say, for testing the technology. So moving the small component of this asteroid out of the way.
The Venusians are toast, but they were already.
Exactly. 470 degrees Celsius, you're pretty well burnt toast as well, I think.
Yes. Wow, that's fantastic. Of course, we know a lot about what's out there at the moment, and by comparison, like this is a 60-meter chunk we're talking about. The asteroid that finished off the dinosaurs was like 15 kilometers in diameter. Yes. And I read that the largest one that we know of in our solar system is nearly 1,000 kilometres in diameter. We don't want to get hit by that.
No, that's right. But that's Ceres, which is actually big enough to be a dwarf planet. And Ceres is well and truly in the main asteroid belt. It's never going to
not moving
anywhere near the Earth. Not as far as
us anyway. Well, that's good to know. Terrific.
Yeah.
All right. Now, it was a good simulation, and I'll be really interested to see how they go with that test to move an asteroid and see if they can actually do it. Because one day we'll probably have to.
One day we might need it. That's right.
Exactly.
So more power to their elbow.
Yeah. All right. You're listening to Space Nuts with Andrew Dunkley and Fred Watson.
0G, and I feel fine.
Space Nuts.
Now, Fred, we normally go into some questions. And we will. But there's a couple of things we need to talk about. One of them is the Square Kilometre Array. That's that collaboration that involves Australia, Africa and New Zealandish land. And the latest news on that is the supercomputer that they're planning to create to kind of crunch all this data they're going to collect. And from all reports, this is going to be one mega device. I mean, it'll far outweigh anything that's ever been created before.
That's absolutely right. Let me just start, though, with a correction there. And the correction's not...
No, I never make mistakes.
No, you didn't. It was me who made it.
Oh, really?
Because I told you some time ago that New Zealand would be part of the Square Kilometre Array. And indeed, that was the original plan. But during... the time when the final layout of the Square Kilometre Array was being decided, it turns out that the antennas for the Australian end of it will all fit into Western Australia. So you don't need to extend it beyond the boundaries, actually not even beyond the boundaries of the state, let alone the boundaries of the nation. So, yes, it's the Kiwis are certainly part of it in the sense that they are collaborators in the program. There are 40 countries involved with the Square Kilometre Array, so they are very much a part of the show, but it won't extend onto New Zealand soil.
Fair enough. Okay, I understand. And they didn't have enough wool to build the antennas anyway, so...
Yes, quite so.
Sheep joke, sorry, can't help it.
It's all right. No, we'll let you off, don't we? The really interesting thing, I think, right from the beginning of the Square Kilometre Array project has been that the amount of data that it will produce has always been thought to be greater than the capabilities of data analysis hardware and software at the present time, whatever the present time happens to be. And that's still the case. The amount of data that it will produce is colossal. I'm actually just looking for the figure as we speak, but I can't remember. It's a colossal number of petabytes.
It's just astronomical. They're talking petaflops and petabytes and...
Yeah, that's right. It's huge quantities. So, I've seen it put in terms of how big the pile of mobile phones will be that was taking the data for 1 second from the Square Kilometre Array. So it has always been regarded as one of the future challenges of the Square Kilometre Array was to produce the data. The data analysis hardware and software. And the reason why we're talking about this is that is in the news, and it's because the design has now been completed for something called the SDP, which is the Science Data Processor for the Square Kilometre Array. And the bottom line is that it will be the fastest in the world. It will beat every other fast computer, hands down.
Well, the fastest one at the moment is IBM's Summit. And
yes, that's right.
This one, they reckon, will be 25% faster.
Indeed, that's correct.
A computing power of around 250 something flops.
Petaflops. That's right.
That's the word.
So it's 600 petabytes of data every year. And you divide that by 365 to work out what it is in a day. It's a lot. And a petabyte, of course, is 1,000 terabytes, and a terabyte is 1,000 gigabytes. So you're talking 1 million gigabytes there. So yeah, colossal amounts. The data speed I think this is fantastic, is 100,000 times faster than the average global broadband speed in 2022.
Which makes it 1 million times faster than Australia's NBN.
It's just they're mind-boggling numbers, and they've always been mind-boggling numbers. And I guess it's only now, in something like the 10th year of the SKA project, that we're starting to really come to terms with it, with the design of the SDP, the Science Data Processing Centre. And it's great to see this. I think this has been regarded as something of a triumph, because you can have blue sky ideas and say, oh, yes, the technology will catch up. That's all very fine. But to actually design the technology before it's caught up, I think that's pretty impressive.
It is indeed. And what amazes me even more in the story is that they'll be able to get all the parts from Radio Shack. I think that's fantastic. I don't know. But yeah, I'd love to have a computer like that at my place. But I'd be dreaming. I don't think I could afford the 10th mortgage.
all you'd use it for would be recording Space Nuts. So it'd be a waste of a good computer.
Editing music, yeah. I think most people underutilise their computing power at home. I really believe that. Yes, you're listening to Space Nuts. Of course, I mentioned the last couple of weeks that we now have a YouTube channel. So if you search for Space Nuts Podcast on YouTube, you will find us. All our episodes are now uploaded to YouTube. And I think, Fred, we now have over 70 followers on YouTube. Our magic target is 1,000. So we're hoping to get that many people at least following us on YouTube, and it's such a popular platform. I'm very hopeful that we'll do that. The other thing that we're doing is we have a Patreon account for people, and this came from the audience. People wanted to contribute to the program in terms of actual dollars, and so we now have a bunch of people that are doing that, and we just want to send a big shout out and thank you to Mark Snelson, Hannah Webb. Now, I remember the name Hannah Webb, and I suspect she's the airline pilot that sent us those noctilucent cloud photos. So Hannah's involved in this. Dan Thompson, David Watson, Tim Gibbs, who's one of a couple of people who actually initiated the idea of us creating Patreon, Sydney Dark, and Nicholas Lindsay. So thank you all for supporting us. We're chuffed. It's fantastic, Fred, isn't it?
It is. It amazes me, actually. It astonishes me that we've got this level of support from, given the really rather poor quality of our product. I think it's quite astonishing.
Speak for myself.
I shouldn't do it down. I think you and I, between us, we do a half decent job.
Well, we try. We're very trying.
Yeah.
Yes. But thank you all. Now, I did mention Mark Snelson. Mark has actually sent us a question a few light years ago, which we are going to get to right now. Thank you, Mark, for your question, and thank you for pitching the Patreon idea. A couple of people have come to us with it. He said, I recently started being fascinated by and following the position of the International Space Station on ESA's website. Can Fred explain why this particular orbit, 51.64 degrees, according to Wikipedia, was chosen for the ISS? The ESA site says that the ISS sees 16 sunrises and sunsets every 24 hours. That'd really kill your sleep cycle. Would a satellite in 90-degree orbit see more or fewer? What about one in 0 degrees orbit? Thanks, and keep up the good work. And he goes on to say, by the way, how can we listeners donate? Well, it's done. Thank you, Mark. It's awesome.
Yeah. Good. Congratulations, Mark. You did a good one there.
Now, good question.
So, really interesting question. And it's got a fairly complicated answer, but let me just try and summarize what the issues are when you put something like the International Space Station into orbit. If you want to save energy and have the kind of minimum energy that's needed to get all these huge bits of hardware up into orbit, what you want to do is put it in an equatorial orbit, one that goes around the equator, because that's the way that you get the biggest. If you're launching from the equator, that's how you get the biggest bang for your buck. You get about 1.5 kilometers per second free. It's just a bit less than that. It's about 1 kilometer per second free of the 8 kilometers per second that you need, because the Earth's rotation actually propels you into space in the right direction, assuming you launch to the east. So that's the reason for going for low inclination orbits. Of course, if you want to surveil the whole surface of the Earth, then you need a high inclination orbit. You want to be at 90 degrees so that you can see the entire planet passing between you, beneath you, at certain times in the orbit. And that's why most military spacecraft are in what are called polar orbits. They go over the north and south poles. So it's usually a kind of a compromise between those two extremities. And apparently the bottom line with the ISS orbit is all to do with the practicalities of launching astronauts there from the Russian launch facility in Baikonur. It turns out that 51.6 degrees is actually the lowest inclination that you could directly launch in from Baikonur. So if you're going to be using Soyuz spacecraft, and of course that's been the workhorse of getting astronauts up and down to the ISS for ever since 2011, then you've got to have a spacecraft in that orbit. And the mission planners for the ISS, who of course, it was a fully international venture, so the Russians would definitely have put in their bid for that inclination so that they could access it directly. And it's a totally valid reason for doing it. You know, it's which has turned out to be extremely valid because for the last 7-8 years, there haven't been any human launches from Cape Canaveral.
Wow.
So that's the bottom line.
Okay.
Just going on to the next bit of the question, though, it doesn't actually make any difference what inclination orbit you're in. This is the angle of inclination to the equator, as to the hours of daylight and darkness you see. It's still every 90-ish minutes that you go around in orbit, because what controls that is not the angle of the inclination. It is the height above the Earth's surface. The higher you get, the longer you take to go around. But at the height of the ISS, it's, as you said earlier, it's 16 times in a day. And if you think about it, you've always got half the Earth in daylight, half the Earth in shadow. So it's really not going to make any difference what angle your spacecraft is at to the equator as to how much darkness you see. You'll always have a daylight and darkness every 90 minutes.
Yeah, and of course you can't slow down because then you don't stay up there.
Yes, that's right. Indeed, you come back down to Earth very quickly if you slow down.
Or you bounce off and end up in oblivion. Thank you, Mark, for more than one reason, but appreciate the question and hope we managed to sort it out for you. Now we move on to a question from, all I've got is Simmons, so I'm pretty sure Simmons will know who Simmons is. And Simmons, thank you for your question. Now, he says, or she says, I'm assuming it's a surname. Do you think Fermi's paradox means there is probably no technologically advanced life in our galaxy? I'm coming to believe this is true, even to the point that it's unlikely there are other intelligent life, or there is other intelligent life currently in existence in our galaxy. Oh, Hugh, there. Sorry, it's separated on the lines. Hugh Simmons. Thank you, Hugh. We have talked about this before, and I think we concluded last time we discussed it that it's starting to look like we are an anomaly. I can answer part of Hugh's question by saying, well, there is actually intelligent, technologically advanced life in our galaxy because we're it. But beyond this place, yes, it's a big question mark over that.
So, yes, you pretty well answered the question there.
And thanks for coming. We'll see you next week.
There's just a little bit more to it, perhaps, that we can add. Fermi's paradox, which was posed back in the 1960s by Enrico Fermi, a well-known Italian physicist. The question is, where are they all? Because if you say, okay, intelligent life is possibly commonplace throughout the galaxy. In particular, it may well be that in some parts of the galaxy, intelligent life evolved much, much earlier than we have. And so if that's the case, why don't we see evidence of that intelligent life, either in radio signals leaking from extraterrestrial communications or from spacecraft that visit you? Because even if it takes, a million years to get from one star to the next, as it might if you're using normal chemical propulsion, if you've got a civilization that's long enough, that has lasted long enough, that shouldn't be a problem. You have long space journeys with colonies of people on board, and they just carry on their normal daily lives, but they're not on a planet, they're on a spacecraft. And then they get somewhere else, and then they, build another one. And so you essentially have this, this multiplication of life throughout the galaxy. We don't see that. We see no evidence whatsoever of intelligent life. And so Fermi's paradox is still asked, but I think Hugh's point is well made, because the astrobiology community, I think, is leaning towards exactly the viewpoint that he's expressed, that it seems increasingly likely that we are, exactly as you said, we're an anomaly. We're a weird freak of circumstance within what would otherwise be a perfectly normal star system with planets and things like that, but nothing worthwhile in the idea of intelligent life on it. And we're glossing over how you define intelligent life. I think it was Carl Sagan who defined it as being organisms that are functionally the equivalent of ourselves. That means they can do what we can do.
Well, that's the standard we've set, isn't it?
It's the standard we've set. It's the only one we know about.
It's pretty low, but it's the standard. It's the standard we've set.
Speak for yourself.
Well, I'm lower than you, I think.
No, I don't know. I think I've got the functional equivalent of your average ant sometimes. Anyway, that's not ant, A-N-T. The other thing that feeds into this is the view that I think is also growing, that while microbial life might be common throughout the universe, the step to get from a microbe to a multi-celled organism, and then thence to vertebrates and primates and humans and all the rest of it, that first step is one that demands huge quantities of energy and could be extremely rare. And the reason why scientists point to that is that, as far as we know, it only happened once on Earth, or at least it only succeeded once, because what's called eukaryotic life on Earth, multi-celled life, can be traced back to a single ancestor. It's called Luca, the last universal common ancestor. So if we'd found traces of a different common ancestor on the Earth in the genome of some species, then you might have said, well, okay, it has happened more than once, so it might happen more than once in the universe. But the fact that it's only happened once in the 4.6 billion year history of the Earth leads to the suspicion that even plant life might be very rare throughout the universe, let alone intelligent life. So Hugh's point is well made. It's an interesting one that would answer the Fermi paradox very neatly. Why don't we see them? Where are they all? Well, they're just not there. At least they're not there yet.
Well, that's the other side of it. We might be first, but it might happen again. But by the time it sort of reaches the level we're at, we might be well gone too. So it's just, And would they be able to find evidence of our activity? Depends where they are in the universe.
It does indeed. There are permanent reminders of humankind in the shape of not just the radio emissions from the Earth, but the 5 spacecraft that are leaving the solar system, all of which carry anything from little plaques to human ashes. New Horizons has an ounce of Clyde Tombaug's ashes on board it, the discoverer of Pluto, and the other thing is the LP records on the Voyager spacecraft, launched in the 1970s using 1970s technology.
And everyone whinged about it because the technology's changed and we've gone digital. But vinyl made a comeback.
Yeah, it did indeed. Yeah, and there are instructions on it how to play these things.
We're assuming they can read. So we make a lot of assumptions, don't we? But
pictorial depictions. So if they don't have eyes, yes, there's a problem there.
Yeah, well, we didn't think of that, did we? Anyway, it's something we'll continue to ponder. I mean, really, we don't know absolutely, and you can never say never.
You can never say never. That's right. because there are 10 to the power 23 stars in the observable universe, and each one has probably got a planet or two. So that's a lot of stars to go and check out.
And it brings you back to that old analogy. If we're the only ones, it's a hell of a waste of space.
It raises all kinds of existential questions like, why are we here? And what's it all for? And why do people listen to Space Nuts?
That's the biggest question of all.
Oh, yeah.
And we hope they will continue to listen, and we thank them very kindly for their support, their questions, their comments, their observations. We love it all. And thank you, Hugh, for your question. Thank you, everybody, for listening. And thank you, Fred, as always, for providing us with so much great information. It's terrific.
It's a great pleasure, Andrew, and good night to everybody, or good morning, or whatever time you're listening, and we'll speak again next week.
Professor Fred Watson, and from me, Andrew Dunkley, thank you so much for listening, and we'll catch you next time on Space Nuts.
Space Nuts. You've been listening to the Space Nuts podcast.
Mission complete, Houston.
Subscribe to the full podcast on iTunes and Stitcher or your favourite podcast distributor.
This has been another quality podcast production from Bytes.com.